Hello everyone, welcome back to ANR Academy. This is Nepalati sir. Today we are going to discuss how to find oblique distance from given point Px1 y1 with respect to given line ax plus by plus c equal to 0 if alpha is angle made by the line passing through the point P with positive direction of x-axis in the counterclockwise sense. In general, distance from point to line is the perpendicular distance from given point to given line. But here the discussion is not perpendicular distance, remember, it is oblique distance. That is, here the distance we are going to measure here PQ, which does not perpendicular with respect to the line ax plus by plus c equals 0. When the angle made by PQ with the line, if it is not 90 degrees, then PQ distance is known as oblique distance, remember. Just distance means that is always perpendicular distance. Particularly here mentioned oblique distance. Distance is not perpendicular. Such type of distances now we are going to find, and also after this we will discuss how to find oblique distance between given parallel lines. In general, distance between parallel lines that is measured perpendicular to both the lines. This dotted lines indicates perpendicular distance between parallel lines. But now today we are going to discuss how to find oblique distance between the parallel lines when the line makes an angle alpha with positive direction of x-axis in the counterclockwise sense. See first one. Here there is a point P x1 y1 and alpha angle made by the line passing through the point P with positive x-axis in the anticlockwise sense. Now we need to find distance from point P to the line. Here the point of intersection of two lines, suppose Q. Next, to find the distance between these 2 points, here the requirement is P x1 y1 as well as we need coordinates of Q also. If you know the coordinates of both P and Q, then it is easy to find the distance between them. Let us see what are coordinates of Q. Suppose that R is the distance from P to Q. Then the coordinates of Q with the help of parametric form, I can write x1 plus R cos alpha, y1 plus R sin alpha. These are coordinates of Q. See here, the point Q which lying on the line ax plus by plus c equals 0. Therefore, the coordinates of Q satisfies the equation of line. I am going to substitute here x value x1 plus r cos alpha, y value y1 plus r sin alpha. Yes, a multiplied by x is x1 plus r cos alpha. Next, plus b multiplied by y coordinate y1 plus r sin alpha plus c, which is equal to 0. Here ax1, by1, c you have ax1 plus by1 plus c, keep in bracket, remaining terms a cos alpha, b sin alpha you have, that is plus a cos alpha plus b sin alpha, it is equal to 0. And also you have r from these two, so here I am going to write r also. Our aim is to find distance from P to Q, that is here clearly small r. Therefore, I can write r of a cos alpha plus b sin alpha, which is equal to minus of ax1 plus by1 plus c. Therefore, the value of r equal to minus of ax1 plus by1 plus c divided by a cos alpha plus b sin alpha. Here PQ is small r and clearly r is distance between 2 points. Distance always positive, so that taking modulus sign we get modulus of ax1 plus by1 plus c divided by modulus of a cos alpha plus b sin alpha. This is the formula to find oblique distance. Suppose if you need oblique distance from point origin to the line, then what happens, observe. Suppose if the point P whose coordinates origin and there is a line, suppose this is ax plus by plus c equal to 0, and assume that alpha is angle made by this line with the positive direction of x-axis in the counterclockwise sense. Suppose that is alpha. In this case, the distance r, that can be written as, just in place of x1 y1, now you have to write origin 0 comma 0, right? Substituting in place of x1 y1 0 0, we get modulus c by modulus of a cos alpha plus b sin alpha. So this is distance from origin to line. Yes, that is oblique distance from origin to line. Let us move to the next concept, oblique distance between parallel lines. Here it is very simple. Just draw a line which is parallel to this line and which passes through origin. We need to select a line parallel to this passing through origin. Suppose this one. This is the parallel line and clearly it passing through origin. These two are same. This is required distance, suppose d. This is also d. Why? Because these two are parallel. Next, see here, by our previous discussion, origin to any line, oblique distance formula you have mod c by a cos alpha plus b sin alpha. The same I am going to apply here. To find small d, what I am doing, observe. First I am going to find oblique distance from origin to first line. From origin to first line, find d1 oblique distance, and origin to second line, assume that this is oblique distance d2. Then the difference of these two gives oblique distance between parallel lines. Therefore, here I can write the value of d as d1 minus d2. Yes. Now, let us substitute oblique distance formula d1 and d2. d1 is distance, oblique distance with reference to first line. Yes, here oblique distance from origin to given line, that is modulus c divided by a cos alpha plus b sin alpha. Here modulus c means modulus c1 divided by coefficients here ab and here the angle alpha, so that this is transversal, these two are parallel, and hence this is also alpha. Therefore, I can write d1 value mod c1 by a cos alpha plus b sin alpha minus next d2, that is oblique distance with reference to second line, so that you can write modulus c2 divided by a cos alpha plus b sin alpha. Therefore, oblique distance between parallel lines, now you can write modulus c1 minus c2 divided by modulus of a cos alpha plus b sin alpha. So this is the formula to find oblique distance between given parallel lines, and this one is oblique distance from given point p x1 y1 to the line ax plus by plus c equals 0. Here in the numerator part, you can also write the notation modulus L11 divided by modulus a cos alpha plus b sin alpha. This is the formula for oblique distance from point to line as well as distance between given parallel lines. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.